Okay, so let's use some other filters to make sure that you practice with filters. Once again, download the Wireshark captures. I'll start a capture on this side, and I'll start a capture on this side. So if you want to follow along, then download these Wireshark captures and see if you can do the filtering yourself. So I'm going to go to PC2 and I'm going to make connections to the server. So on PC2, I'll clear the ARP cache, and then let's ping gns3.com. Notice the ping succeeds. The name was resolved, so gns3.com was resolved to the IP address, and I'm able to ping that IP address. What I'll do is open up a web browser and go to gns3.com. That succeeds. So I'm able to browse to the GNS3 server without any problems. Okay, so let's have a look at Wireshark. So first thing is, let's have a look at this capture on the right-hand side. This is from router to switch 2. And what I'll do actually is stop my Wireshark captures. And I'll save them for you. So save as PC2 GNS3. And this one I'll save as PC2 GNS3 left. Okay, so on the capture on the right-hand side, if I do a search for ARP, I'll be able to see that the PC is ARPing for the router's MAC address. This is the PC's IP address, this is the router's IP address, and the router's replying back with its IP address. The router replies back with its IP address because the router is going to route from one interface to the other. This server is on a separate subnet to the PC. Remember, the PC has IP address 10.121/24 mask. The server, however, has IP address, and this is Linux, so it's ifconfig rather than ipconfig as a command, has this IP address and this subnet mask. It's in a different subnet to PC2. If you're not sure about IP subnetting and what I've just explained, remember you can get free access to my CCNA course, so send an email to sales@configuredterminal.com if you want to get free access to my CCNA course. And in that course, I explain a whole bunch of things with regards to basic networking, subnetting, etc. So the router will tell the PC its MAC address because the PC is going to send traffic to the router to route to a different subnet. DNS is also shown in the output here. So filtering for DNS, I can see 10.121 is sending the DNS request to the router. But on the right-hand side here, you'll see that this is a different domain name than gns3.com. So notice it's looking for microsoft.com. But at this point here, we can see a query for gns3.com. So the PC is querying the router for gns3.com. We can see standard query, querying this domain name, gns3.com, and then the router replies back with the information about that domain. So scrolling down, notice IP address. So by filtering for DNS, we can see that information. I could have, as an example, filtered on protocol. Now notice this is a UDP. So this would be UDP port 53, and we'll see something similar. PC is querying from a random or ephemeral port to the DNS server on port 53. There's the query, and here's the response back again. Source port is 53, going to the ephemeral port on the PC. PC now knows IP address of the server. So I could, as an example, filter for ICMP. So there we can see ICMP echo request and ICMP echo reply. I could, as an example, have filtered for IP destination and filtered for the IP address of the server. So something like that. So here we only see echo request messages, not echo reply messages in ICMP. But I also see the HTTP messages from the PC to the server. So here's HTTP GET message. And we see the TCP and HTTP messages from the PC to the server. But you might just want to filter on HTTP, which shows you everything. So PC to server, server back. PC to server, server back to PC. So again, looking through the HTTP information, we can see Hypertext Transfer Protocol, and scrolling down, we'll be able to see information encoded in the HTML. So here's the actual HTML document called Networkers Toolkit. We can see that on the PC. That's again what was displayed over here. So various information is shown in the HTTP stream. Now just be careful when capturing traffic once again. Traffic that you see over here will be different to traffic over here. So as an example, if PC2 pinged the router, you wouldn't see that query over here. You wouldn't see that information on the left-hand side. And to prove that, here's the capture from switch 1 to the router. So switch 1 to the router. Let's do a search for DNS. Notice we see no DNS queries. What about ICMP? We see the ICMP messages because they traversed this link. When PC2 sent traffic to the server, it would have traversed this link. So we can see it in Wireshark, but we don't see the ARP messages from this PC to the router. We see the ARP message from the server to the router, not from PC2 to the router. So notice the server is asking who has IP address 10.1.1.254. So target IP address, this is the sender IP address. And then the router replies back with its MAC address. So the server ARP message is seen on this side. The PC2 ARP message is seen on this side. And that's again because this is a router. It's separating broadcasts. Layer 2 switches will flood broadcasts, but a router won't. Remember, the router is separating traffic. So traffic locally here is not forwarded to the right-hand side. So again, you need to be careful where you're capturing your traffic. But that was an example, once again, of how to use filters. Don't forget about where you're filtering. Don't forget about your network types. If this was a layer 3 switch or had VLANs implemented on it, you'd have to be careful where you're capturing your traffic.